Lesson 54 of Saxon Algebra 1 begins by talking about the substitution axiom. Saxon defines the substitution axiom in this statement right here. If two expressions A and B are of equal value, A equals B, then A may replace B or B may replace A in any expression without changing the value. Also, A may replace B or B may replace A in any statement without changing the truth or falsity of the statement. Also, A may replace B or B may replace A in any equation or inequality without changing the solution set of the equation or inequality. So all they're really saying there is when they give you either an expression or an equation, and then they give you some parameters of what you can substitute for those variables, they're saying you're allowed to substitute them for each other without changing the outcome. So here's their example over here on the right. If you're given x squared times y divided by p, and then they also give you a set of when each of those variables equal particular things, the substitution axiom is what allows you then to plug things in and substitute. So in this situation, we have x equal to a 2. So if we rewrite the equation, plugging in a 2 for the x, I'm going to keep the squared there as well. And then if y equals 4, I'm going to plug in the 4 for y. I'm going to put a parenthesis so I don't forget these are being multiplied by each other. And then here they're saying p equals a -1, so I plug the -1 in for the p. Then I can solve this, so this becomes 2 squared, which is 4, times a 4 divided by a -1. So this becomes 16 divided by a -1, so it becomes a -16. So that's the substitution axiom. It's just sort of giving you that permission that when you're given things equal to new numbers, you can plug them in and substitute them in freely without changing the value of the equation. The next portion they talk about in lesson 54 is simultaneous equations. So we're going to start this by starting with two equations. You're given equation A, 2x minus y equals 1, and equation B, x equals -3y plus 11. They say we can see that 3, 5 is a solution, 3, 5 is a solution to equation A, and 5, 2 is a solution to equation B. So basically this is a point that can lie on this equation, and this is a point that can lie on this equation. So they found this, or to check this, we're going to plug that point back in and see if it's true. So again, any time we have a point written, it's written as x, y. So we can take the first one and use that substitution axiom to remember we can plug that 3 in now for any x. So I'm going to plug the 3 in for the x. Again, I'm rewriting this equation here, plugging things in. And then we have a 5, so I'm plugging that in for my y. And then if I solve this, this becomes 2 times 3, which is 6, minus 5. And in fact, 6 minus 5 is 1. And that does in fact equal 1. So now that I got to this point at the very end, I can say that is in fact true, that 3, 5 was a point that satisfied this equation. And then we're going to test equation B, plugging 5, 2 into this equation. Again, not forgetting that the 5 is our x and the 2 is our y. So I'm going to rewrite this equation, plugging in 5 for x, plugging in 2 for y. So this becomes -6 plus 11. And -6 plus 11, in fact, does equal. So since that does equal 5, that one is also true. Now, neither 3, 5 or 5 comma 2 is a solution to both equations at the same time or simultaneously. If we need one solution that can satisfy 2 or more equations, we call the equations a system of simultaneous equations. And when we talk about a system of equations, it's written like this. This is my favorite little symbol to write. It's just a fun little curly thing, but we are going to write them together, not as 2 separate problems like we had above. If we write them together, let me fix that real quick. If we write them together, now these 2 equations are written now as a system of equations. And that involves a very different relationship because these are very separate over here. And now that we're seeing them as a system, we'll move on to the next part that Saxon talks about, which is solving simultaneous equations by substitution. So we will solve these 2 problems by using the concept of substitution to find their x and y values. And again, we have an xy value that solves this problem. And we already know one that solves this one, but now, since they're a system together, we want to find a very specific XY solution that solves both of them. So to do that, because this one is already set x equal to something, that means we can plug in everything x is equal to into the x of the first equation. So I am going to rewrite the first equation. I'll just rewrite it fully right here. And then I'm going to plug this whole value in for the x. So I will show you that in different colored. And I still have, again, I'm rewriting this same equation, so I'm not forgetting the rest of this equation. I'm just plugging in this value right here for my y. Once I do that, I can now solve the equation by first distributing the 2 in. So 2 times a negative 3y is negative 6y. 2 times 11 is a positive 22. And then I'll rewrite the rest of the equation. Now I'm going to add like terms because I have negative 6y and a negative y. Together that makes negative 7y. Then I'll just rewrite the rest of the equation. And now I'm going to subtract 22 on both sides of the equation. So I end up with a negative 7y equals a negative 21. And now I will divide both sides by negative 7. So these cross out and I have y equal to a positive 3. So I'm almost there. I'm going to box that answer, but I'm not quite done because again, my goal was to find an x-y ordered pair, and I just found that y equals 3. So I know this piece of it. I still need to figure out what x equals. So now that I know y, I can choose either one of these original equations and plug the y in to solve for x. Since the second one here is already solved for x, that will be the easier one to use. So I'm going to do that one over here. I'll just rewrite that equation. Again, since our goal is to solve for x, since it's already solved for x, it'll make it easier. So I'm going to rewrite it, plugging in the 3 for my y. So I'll get negative 9 plus 11. So in the end, looks like x equals a positive 2. So I will box that, and then I can enter that 2 here. So the point 2, 3, or the ordered pair 2, 3, is the only point or set that satisfies both of these. Again, when we put this little system symbol on, that's what we're searching for. Not just one that will satisfy one or the other. It needs to satisfy both. All right, do some practice problems in this set and let me know if you have any questions.